Jack. Hi everyone. My name is Dr. Kay Weltz and I work for the Conservation Ecology Centre. I'm going to speak to you today about filling the gaps, collaborating for marine resilience along the Otway coast. And no, I'm not going to sing for you this year. I did think about dressing up as a mermaid though, since that's what my kids think I actually do for a living. But then I just thought, but then I have to outdo myself next year, and let's just end this vicious cycle now. So, well, what an incredible day it's been. We have journeyed from forests and heath country to invasive species and now all the way to coast and sea country. It's a privilege to close this session and this session's presentations today, and so I'll keep it really high level and kind to your brains, which I know are full after a big day of listening. Before I begin, I'd like to acknowledge the first peoples of the land and sea we are gathered on today, the Gadabunuk clan of the Eastern Maar Nation. We acknowledge the deep and enduring connection the Eastern Maar have with the sea country, and we pay our respects to their elders, past and present. The Otways coast and ocean are an iconic and beautiful stretch of Victoria. Every summer, we see around a 300% increase in tourism. People travel here to visit the 12 Apostles, to walk the Great Ocean Walk from Apollo Bay to Princetown, or to drive the Great Ocean Road from Torquay to Warrnambool. This coast is not just economically important, it is ecologically diverse, culturally significant, and deeply meaningful for local communities. Its beauty and richness make it one of Victoria's most treasured landscapes. But despite this significance, there is a major marine monitoring gap along the Otway coast. Between Anglesea and Warrnambool, including the Marengo and 12 Apostles Marine National Parks, we have very little up-to-date data. The last subtidal reef surveys were carried out by Parks Victoria in 2015, shown here on this graph by the green dots, and by the Victorian Fisheries Authority in independent diver surveys in 2016, which is the blue line along the coast because there were many. That's nearly a decade ago. Intertidally, the last comprehensive study by O'Hara et al. Focused on biodiversity patterns and threats, data collected in 2005, 20 years ago. Other trips by field naturalist groups have occurred recently, but these are largely focused on species taxonomy and not ecosystem health and threats. At present, the only regular monitoring we found includes hooded plover surveys dotted along the coast by BirdLife Australia and some ongoing marine monitoring at Point Addis Marine National Park in Anglesea and Mary Marine Sanctuary in Warrnambool, shown here by the yellow dots. But nothing covering this long central stretch of coastline in between, including the Great Ocean Road and the Great Ocean Walk. Bit of a delay. Jack, your computer is letting us down today.
We really
not
are stuck
doing anything.
relying on me for
I know.
this is born.
No, thank you. I'll use this one. Happens every time. I feel like it's planned. So the question is, how do we manage climate and human impacts if we don't know the baseline health of these systems over the last 10 to 20 years? How do we detect changes early, like overabundant urchins or declining kelp forests? Well, rehabilitation is often far more challenging and costly than prevention. And this is where the OMA initiative comes in. The Otways Marine Ecosystem Resilience Initiative, or OMA initiative, is a collaborative project with 3 key pillars. 1, scientific research and monitoring, led by the Conservation Ecology Centre. 2, Indigenous ecological knowledge and leadership, overseen by Eastern Maar Aboriginal Corporation. And the community stewardship, coordinated through Otway Ocean Care. Our purpose is to fill knowledge gaps about ecosystem health currently and resilience. And our goal is to establish ecological baselines, then build ongoing monitoring to guide conservation, stewardship, and management for a resilient Otway coast. Under the first pillar of research and monitoring, the OMA pilot study, supported by the Wetton Hall Environmental Trust, focused on 5 highly vulnerable unmonitored marine sites from Cape Otway to Skeens Creek. These include Crayfish Bay, Parker Inlet, Blanket Bay, Marengo Reef and Beach, Apollo Bay Harbour, and Skeens Creek. At each location, we surveyed intertidal reefs from high tide to low tide mark and or subtidal reefs below the water surface, depending on what was present and appropriate. We used 2 complementary approaches. First, biodiversity and observational surveys. which include point searches on intertidal reefs and visual observational surveys while snorkeling subtidally. And second, rapid health assessments, or RHAs, which were designed to assess ecosystem condition and current threats. To dive a little deeper into the rapid health assessments, or RHAs, this is a Parks Victoria method we adapted to collect consistent data inside and outside of MPAs. We measured key ecological attributes such as Neptune's necklace or habitat-forming kelp species using indicators such as extent, cover, and connectivity, each indicator having a set of categories, for example, fragmented to fully connected for connectivity. We also set baselines for 4 key mobile macroinvertebrates chosen for either abundance, vulnerability, or poachability, and we recorded frequency and size class. Finally, we also assess both human and climate threats, scoring for each amount and extent, whether they're localized, scattered, widespread, or throughout the sites. Here's an example of one of our locations, Marengo Reef and Beach. Intertidally, we set up 2 survey sites with different aspects and different visitor pressures. That's MRN1 and MRN2. Subtidally, we had 1 MPA site with 2 potential snorkeling routes, depending on conditions and motivation. And also an adjacent non-MPA snorkeling route as well. For each site, we also note specific characteristics and hazards. And together, these sites allow us to compare ecosystems inside and outside protection zones. The second pillar of OMA is Indigenous knowledge and leadership. Eastern Mars Sea Country Guardians have joined us on surveys, sharing knowledge of their sea country while learning marine ecology. EMEC is also leading an Indigenous ecological knowledge review to highlight significant sites and guide their sea country plan for the Otway coast. And importantly, all of our OMA data which we collect on this study is owned by Eastern Mar. For at the core, our partnership with Eastern Mar is about knowledge sharing and placing Indigenous knowledge and values at the forefront of marine conservation and management along the Otway coast. The third pillar is community stewardship. We've had a fantastic response from local volunteers. Up to 15 people have joined our intertidal surveys at a time, anywhere from Apollo Bay locals to people traveling from Melbourne. Otway Ocean Care coordinates the volunteer base, and we're working on engaging younger participants too, for after all, this coastline's future impacts them. We have also promoted OMA through fundraising campaigns, local events and talks live and on radio, helping to build a wider community stewardship and care for these ecosystems. I'll spare you the analysis framework at this time of day, but here are some key preliminary findings. Ecosystem health across the Otways is highly variable, not just between different locations, but even between sites at the same location. Intertidally, as we can see here, at Crayfish Bay, we found plenty of top shelf species and some rare anemones. Parker Inlet stood out with some short-spined sea urchins and little green sea stars. Blanca Bay had particularly rich diversity of anemones and shore crabs. At Marengo, we regularly encountered a resident blue-ringed octopus, which is exciting. And at Skeens Creek, the standout was the abundance of sessile invertebrates, including giant surf barnacles, sea squirts dominating the lower intertidal zones. For Neptune's necklace, connectivity was mostly patchy, with only a few sites showing high extent cover and connectivity. To explain, we combine the 3 indicators, extent, percentage cover, and connectivity, into one final graph. And they come along a spectrum. At one end is Parker Inlet, which is shown by the red box at the bottom, where Neptune's necklace has low extent, low cover, and is fragmented. At the other end, for example, Blanca Bay Site 1, which is the other red box with the green circle in it, with high extent, high cover, and strong connectivity. Most sites fall in between, but overall the pattern is patchy. This approach lets us track differences over time and see where the sites sit, moving up or down the spectrum. Subtidally, Marengo Marine Protected Area had the highest fish diversity, Blanca Bay had the lowest, and Crayfish Bay showed signs of being an important nursery habitat with lots of juvenile species. Seaweeds varied between locations and sites. Crayweed and bull kelp were common across all sites. Golden kelp occurred mostly at Marengo and in Crayfish Bay. Giant kelp was limited at Blanca Bay and moderate at Crayfish Bay. and zigzag and other mid-story species like brown seaweeds and Cystophora and Sargassum dominated at Blanket Bay. We also saw different assemblages of invertebrates with large populations of abalone in Crayfish Bay and on the Cape. And overall, subtidal seaweeds were patchy and fragmented too, though Crayfish Bay stood out with a really healthy giant kelp forest. I don't want you to worry too much about the detail in these figures, but what matters is that they give us a baseline we can use to compare over time and track how biodiversity and ecosystem health are changing. Looking at the threats, the bar on the left, top left, shows the threat score from low in green to high in red, with the photos illustrating examples of, for example, people or dogs or rubbish. And non-climate stresses varied across the sites. So visitor disturbance was highest at Blanket Bay and Marengo, hands out. Dogs at Marengo, foxes at Parker Inlet. Pollution was moderate to high at most sites. Overnutrification and algal growth were also evident near river mouths. For climate stresses, we saw heat stress on Neptune's necklace during hot summers, shell bleaching, and in winter we saw storm damage with many kelp fasts hold fasts ripped off the rocks and washed ashore. These are preliminary results, but they already point to strong human and climate-driven pressures on these ecosystems, and these can be used as a baseline to continue monitoring and for any negative impacts of these stresses. So looking ahead, thanks to a recent Coast Care grant, we're expanding this pilot study both east towards Lorne and west towards Warrnambool, including some more sites. And we're also including the Indigenous Ecological Knowledge Review identified by EMAC through workshops and potential literature review as well. Bigger picture, we're seeking funding to grow this pilot and expanded pilot into a longer-term cost-effective monitoring led by science, Indigenous leadership and community stewardship. OMA is strengthening the partnerships and building new collaborations to fill a critical knowledge gap along this coastline. With sustained support and through working together, we can create a shared framework for stewardship, ensuring that iconic ecosystems and the communities connected to them remain resilient into the future. And finally, I wanted to thank everyone who's made this project possible. Our funders, my colleagues at CC, our partners, EMAC and Otways Ocean Care, our interns, and of course, our incredible volunteers. This project has been a little dream of mine, and I'm so glad to see it coming to life, and I'm excited to see where it's going to take us. So before I end, just to close, if all of this information has gone in one ear and out the other, because it is the end of a very long day, I'll leave you with a very short video summarising the project. Do you love this coastline? So do we. Whether you live here, holiday, surf, swim, dive, fish, or simply breathe in the beauty of the Otway coast, a healthy ocean is central to our life here. And right now, we don't know how healthy these marine ecosystems are or what threats they're facing. The Conservation Ecology Centre is working with traditional owners and local communities to fill this crucial knowledge gap. By understanding the baseline state of our marine environments along the Otways and the pressure from human activity and climate change, we can shape strategies to safeguard them, ensuring resilient coasts, thriving biodiversity and strong coastal communities. But ultimately, all our lives depend on a healthy ocean. Thank you.